That's why I taken this. So now we are moving to the last part of this video on concept class today, and that is a very important thing which already some part we discussed in the first video. That is called principal stresses, and the continuation of that principal stresses only comes under the one more topic called as Morse circle. In that concept, while discussing this concept is not discussed. Now I'm going to take up this. Now in the interview, these are the questions will be there. Some for your senior, they asked about this. What is Mohr circle? What is the use of that? What is plane stress? So all those things they are asked in that. So now we're going to cover that very interesting topic called as Mohr circle. So before that, it is mainly Mohr circle we are going to take up. So it is comes under the topic called as stress transformation. So we'll see that first stress transformation is what, and before that we're going to take up the stress transformation. We're going to take up first what is plane stress. Okay, so this is very important because every design what you've done, DME, entire DME is deal with this plane stress. So first let me understand here. So plane stress means basically we are going to use for the 2D problem case. Okay, so most of the things we are going to use the 2D problem. 2D problem means usually we talk. Suppose you take a body like this. Suppose you take this bar. Okay. So now what is happens here bar? Basically here let's say length is more, breadth is more, whereas this thickness is less. This for what is happens now. So the thickness on the thickness direction, what are the stress will be developed? That will be in a less significance. Okay, that will not much going to affect. So therefore, what we're going to do is we are going to convert this 3D problem into 2D problem. So what is happens when we convert the 3D problem into a 2D problem? Our computation time become less, and it make our to do a design become very easy to do that. That's why most of the in the design we are going to take up the 2D form. But when we consider 3D means when all three dimensions are significant, like length, width, depth, whatever it be talking about, all three dimensions are significant, then you can't definitely the stresses on particular direction will be maximum will be there. So that case we are going to deal with a 3D problem. Otherwise we go for the 2D. Even suppose only one dimension is dominant, like bar, suppose bar like this, then shaft example, because their length is more than the diameter. Okay, then that case we're talking about 1D. Okay, so that is what you done in a ANSYS 1D bar, 2D 1D analysis, 2D analysis. Okay, so bar, trusses, beams, everything comes under 1D because stress on the along the length direction which is more compared to the other two directions. It will not be zero, it will be there, but minimum. That's why they are going to neglect that. But in case of 3D, all three dimensions are considerable, then definitely we go for the 3D analysis only. Basically, in a thumb rule, how they judge this, which is 2D, which is 3D, means when the thickness of the any member, which is goes more than the 15, 20, more than that then they consider the design as 3D. Otherwise, they go for 2D itself. That is the things. So that problem we call it as plane stress problem. Plane stress means it is called as two-dimensional stress. It is also called as two-dimensional stress. Obviously, stress is there means strain is also there. Then it is called plane strain. Am I audible? You are there, right? Okay.
Yes, sir.
Okay, let me take what is plane stress. The condition of plane stress occurs when all the stresses acting component are in same plane. So basically, one plane. Same plane means suppose you take a plate now. So plate is a two-dimension body we could take up now. So here one plane means that is usually along x and y like this. Suppose in this case, example ಈ figure ತಗೋಬೇಕು ಅಂದ್ರೆ x, y ಇದು z ತಗೊಂಡ್ರೆ now tell me which plane the stresses will be developed. xy plane, yz plane or xz plane. ಯಾವ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಸ್ಟ್ರೆಸ್ ಒಂದೇ ಕಡೆ ಡೆವಲಪ್ ಆಗ್ತಾ ಇದೆ, ಯಾವ ಪ್ಲೇನ್ ಅಲ್ಲಿ ನಾನು ಹೇಳ್ತಾ ಇದ್ದೀನಿ. ಎಕ್ಸ್ ವೈ ಪ್ಲೇನ್ ಅಲ್ಲ, ಝೆಡ್ ಎಕ್ಸ್ ಪ್ಲೇನ್ ಅಲ್ಲ, ವೈ ಎಕ್ಸ್ ಪ್ಲೇನ್ ಅಲ್ಲ. ಯಾವ ಪ್ಲೇನ್ ಅಲ್ಲಿ ಒಂದೇ ಕಡೆ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗ್ತಿದೆ ಈ ಫಿಗರ್ ಪ್ರಕಾರ? ಪ್ಲೇನ್ ಇಲ್ಲಿ ಬರ್ದಿದ್ದೀನಿ ನಾನು, ಕೋಆರ್ಡಿನೇಟ್ ಸಿಸ್ಟಮ್ ನೋಡಿ, ಇದ್ರ ಪ್ರಕಾರ ಹೇಳಿ. ಪ್ಲೇನ್ ಯಾವ್ದಪ್ಪ? ಎಸ್, ಗುಡ್. ಝೆಡ್ ಅಲ್ವಾ, ಝೆಡ್ ಎಕ್ಸ್ ಅಲ್ವಾ? ಒಂದು ಎಕ್ಸ್ ಈ ಕಡೆ, ಇನ್ನೊಂದು ವೈ ಈ ಕಡೆ. ದೇರ್ಫೋರ್ ಯಾವ ಪ್ಲೇನ್ ಇದೀಗ? ಯಾವ ಪ್ಲೇನು?
ಝೆಡ್ ಎಕ್ಸ್.
ಝೆಡ್ ಎಕ್ಸ್. ವೈ ಝೆಡ್ ಅಂದ್ರೆ ಲೈಕ್ ದಿಸ್, ಎಕ್ಸ್ ವೈ ಅಂದ್ರೆ ಲೈಕ್ ದಿಸ್. ಬಟ್ ವಿ ಟಾಕಿಂಗ್ ಅಬೌಟ್ ಹಿಯರ್ ನೌ, ಈ ಫಿಗರ್ ಪ್ರಕಾರ ಇಟ್ ಈಸ್ ಎಸ್ ಎ. ಓಕೆ, ವಾಟ್ ಅಬೌಟ್ ಈಗ ಅದೇ ಫಿಗರ್ ನಾನು ಈ ತರ ಬರ್ದಿದ್ದೀನಿ. ಈಗ ಫ್ರಂಟ್ ಹಿಂಗ್ ಬರಿತೀನಿ, ಅರೆ ಸಾರಿ, ಅದೇ ಫಿಗರ್ನ ಹಿಂಗ್ ಬರಿತೀನಿ. ಈಗ ಟೆಲ್ ಮಿ, ಇದ್ರ ಪ್ರಕಾರ ಯಾವ ಪ್ಲೇನು? ಯಾವ ಪ್ಲೇನ್ ಈಗ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗೋದು? ಎಸ್, ಎಕ್ಸ್ ವೈ. Good. So that means the stress will be developed only on the single plane, not any other plane. That is called a plane stress. Okay, keep this in mind. So basically we know in a 3D cases, these are the stresses will be developed totally around 9: sigma x, sigma y, 3 normal stress, and around 6 are the shear stress along x, y, z direction. But here what will happen on the plane stress means that the stresses we only consider along x and along y, whereas on the third direction whatever the component of stress will be there, that we are going to be neglected or zero we consider. That means sigma z is 0, tau xz, tau yz, tau zx, everything becomes 0. ಸೊ ಅದ್ರ ಪ್ರಕಾರ ಏನಾಗುತ್ತೆ, ಈಗ ಯಾವ್ದು z ಕಾಂಪೊನೆಂಟ್ ಅಲ್ಲಿ ಏನೇನ್ ಸ್ಟ್ರೆಸ್ ಇದೋ ಅದು ಇಟ್ ಮೇ ಬಿ ಎ shear stress, it may be a what you called normal stress, that is considered 0. ಸೊ ಅದ್ರ ಪ್ರಕಾರ ಯಾವ್ದು 0 ಆಗುತ್ತೆ? ಈಗ ಇಲ್ಲಿ ಈ ಸ್ಟ್ರೆಸ್ ಟೆನ್ಸರ್ ಅಲ್ಲಿ ಇದು ಇದು ದಿಸ್ ಒನ್ ದಿಸ್ ಒನ್ ದಿಸ್ ಒನ್, ಅಲ್ಲಿಗೆ ಏನ್ ಉಳ್ಕೋತು? ನಮ್ಗೆ ಏನ್ ಉಳ್ಕೋತು? ವಾಟ್ ಇಸ್ ಲೆಫ್ಟ್ ನಾವು? ಇಷ್ಟೆಲ್ಲ ಎಲಿಮಿನೇಟ್ ಆದ್ರೆ ಏನ್ ಉಳ್ಕೋತು ಈ ಟೆನ್ಸರ್ ಅಲ್ಲಿ ಆರ್ ಮ್ಯಾಟ್ರಿಕ್ಸ್ ಅಲ್ಲಿ? ವಾಟ್ ಆರ್ ಥಿಂಗ್ಸ್, what are the stress component is left now inside this matrix? Sigma x, sigma y, tau x y, and tau x. Only 4 stresses will be developed. There are 2 normal stress and 2 shear stress. Keep this in mind. ಇದನ್ನೆಲ್ಲ ತುಂಬಾ ಇಂಪಾರ್ಟೆಂಟ್ ಆಗಿ ಹೇಳ್ತಾರೆ. ಪ್ಲೇನ್ ಸ್ಟ್ರೆಸ್ ಅಲ್ಲಿ ಯಾವ್ಯಾವ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ 2 ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್, 2 ಕಾಂಪೊನೆಂಟ್ ಆಫ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್. ಅದು ಯಾವ್ದಾದ್ರೆ ಸಿಗ್ಮಾ ಎಕ್ಸ್, ಸಿಗ್ಮಾ ವೈ, ಟೌ ಎಕ್ಸ್ ವೈ, ಟೌ ವೈ ಎಕ್ಸ್. These are the things. That is only for 2D case. Okay, so that means suppose you take this is the plane body now, 2D plane body. The stresses along x direction we called as sigma x, and stresses along y direction is called sigma y, that is normal stress. Similarly, the tangential stress are along the tangential direction, tau xy will be there. Now therefore for the any two-dimensional cases, there are only 2 major principal stresses will be there. One is called sigma 1 and sigma 2, where sigma 1 will be the major principal stress, sigma 2 will be the minor principal stress, whereas sigma 3 will be the one more principal stress along z direction, that is we consider 0 here. We are not taking to the account of sigma 3. So as we discussed in the first video, principal stress concept, there are 3 important principal stresses will be there. One is sigma 1, sigma 2, sigma 3. So in the, keep this in mind, in plane stress we are only take up the sigma 1, sigma 2, whereas sigma 3 we are going to neglect. In order to calculate the sigma 1, sigma 2, here we are going to use this equation. I think hope you can remember in your design you are done in the first module. These are the things, sigma 1, sigma 2 case ne ಜಾಸ್ತಿ ಮಾಡಿರೋದು. So and there will be a tau max will be there. In order to calculate the tau max, that is sigma 1 minus sigma 2 all divided by 2 will be going to be use this equation. These are the 3 principal stress equation we are going to use here. Keep this in mind. So basically this plane stress used to convert 3D problem to a 2D problem. Assume that all the stresses in one direction and are equal to 0 and normally applicable for thin structure loaded in a single plane. So we are going to talking about here which are the thin section member is there. Then we are going to design with the 2D, not with a 3D. This is like plate, everything almost in a air space, like aerospace aircraft design, it comes under 2D only. Yakendre we are going to use the what are the sheets and all, that is very thin sheets, okay, thickness is less, other aluminum sheets as well. So we are going to maximum analysis on the flight will be cases like 2D only. But in case of automobile bandaga body bandre 2D, but rest of the other parts are 3D only, ಆ ಥರ ಇರುತ್ತೆ. It's all depend upon the dimensions of that structure, okay. So this is about the plane stress. Hope you understood this. Plane stress ಅಂದ್ರೆ ಇಷ್ಟೇ ತರ ಇಟ್ಕೋಬೇಕು, ತುಂಬಾ ಏನು ಜಾಸ್ತಿ ಕನ್ಫ್ಯೂಸ್ ಮಾಡ್ಕೋಬೇಡಿ. Plane ಅಂದ್ರೆ plane stress ಅಂದ್ರೆ it is only two dimension stress, whereas stress on the third direction is going to be zero. All the stresses will be produced in a single plane. That's all you have to be keep this in mind. Is it clear? Is it clear?
Yes, sir.
All of you?
Yes, sir.
Okay. So now we're talking about very important concept called as a stress transformation equation. Okay. Take an example now. Take an example like suppose, okay, this is one same bar if I consider. A bar only, I'm going to take up one small elementary section like this. Now I'll apply the load on this. Now tell me what are the stress going to be developed. ಯಾವ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ ಈಗ ಈ ತರ ಬಾರ್ ಹಾಕಿದೀನಿ, ಆ ಒಳಗಡೆ ಇರೋ ಎಲಿಮೆಂಟ್ ಮೇಲೆ ಯಾವ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ ಕ್ವಿಕ್ಲಿ. ಇದಕ್ಕೆ ಇಷ್ಟೊಂದು ಬೇಕಾಗಿಲ್ಲ, ಕ್ವಿಕ್ ಯು ಹ್ಯಾವ್ ಟು ಆನ್ಸರ್ ಬಿಕಾಸ್ ದೀಸ್ ಮೆನಿ ಕಾನ್ಸೆಪ್ಟ್ ಐ ಥಾಟ್ ಯು. ಇಷ್ಟನ್ನು ಡೇ ಒನ್ ಇಂದ ಹೇಳ್ತಾ ಇದ್ದೀನಿ ನಾನೀಗ, ಅಂಡ್ ಇಲ್ಲಿವರೆಗೆ ನಿಮ್ಗೆ ಅದು ಐಡಿಯಾ ಬರಬೇಕು. And you are already learned the subject also now. We are end up the module, concept of SOM. Now tell me, ಈಗ ಟೆನ್ಸೈಲ್ ಲೋಡ್ ಹಾಕಿದೀನಿ, ಯಾವ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ ಕ್ವಿಕ್ ಆಗಿ? ಟೆನ್ಸೈಲ್ ಲೋಡ್ ಹಾಕಿದೀನಿ, ಆಕ್ಸಿಯಲ್ ಟೆನ್ಸೈಲ್ ಲೋಡ್, ಯಾವ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗುತ್ತೆ? ಎಸ್, ಇಷ್ಟೊಂದು ಏನಕ್ಕೆ ಬೇಕು ಅದು? ಟೆನ್ಸೈಲ್ ಸ್ಟ್ರೆಸ್. Is there any shear stress will be developed? Is there any shear stress will be developed? No, because load is not acting in tangential direction. Okay, this is the first case. ಅದಕ್ಕೆ those who are not getting this point, watch video number 1 of strength of material. Everything is covered. Principal stress ಅಂದ್ರೆ ಏನು ಅನ್ನೋದನ್ನು ಅಲ್ಲಿ ಕವರ್ ಮಾಡಿದ್ದೀನಿ. Okay, now things are clear now. Only it is normal stress, that too tangential, no other stress, that is shear stress. Okay, things are now first case. What is happens, I'm going second case now. I'm taking that small element like this, I will keep, and I'm going to build like this, that in like in an inclined manner. Now tell me what are the stress will be developed? Same tensile load only. Load is applied here only, no changes. Only the thing is the way of mounting this, that object is changed now. Now tell me what is the stresses will be developed on this elementary object? It is only shear normal stress.
Shear stress also will be developed.
Yes, that's the things of the concept called as principal stress here. Okay, see what is I told you in the beginning of the module 1 of that video. So when stress is not only depend upon the direction, it is also depend upon the plane. So now what is happened in the first case, it is only under this single plane. Okay, but the plane is now really like this now, but the plane is now neither be vertical nor be horizontal, is now oblique. When there is a oblique, the effect on the both the direction will be there. Definitely here stresses will be developed on both directions, that is normal stress, even that shear stress also going to be developed. So now here this how much normal stress, how much shear stress depend, it will be developed, it is depend upon that the angle of inclination of this theta. Now this is called stress transformation. ಫಸ್ಟ್ ಏನ್ ಮಾಡ್ತು, ಪ್ಲೇನ್ ಅನ್ನ ನಂಗೆ ಇಟ್ಟಿದ್ದೆ, ಇದನ್ನ ನಾನು ಏನ್ ಮಾಡಿದೆ, ರೊಟೇಟ್ ಮಾಡಿದೆ. ವೆನ್ ಐ ಗೋಯಿಂಗ್ ಟು ರೊಟೇಟ್, ಇಟ್ ಗೋಯಿಂಗ್ ಟು ಡೆವಲಪ್ ಸಮ್ ಸ್ಟ್ರೆಸ್. ಹೌ ಮಚ್ ಸ್ಟ್ರೆಸ್ ವಿಲ್ ಬಿ ಡೆವಲಪ್ ಬಿಕಾಸ್ ಆಫ್ ದಟ್ ಪ್ಲೇನ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್. ಏನ್ ಮಾಡ್ತಾ ಇದೀನಿ, ರೊಟೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಹೌ ಮಚ್ ಐ ರೊಟೇಟಿಂಗ್ ಆಂಗಲ್ ಥೀಟಾ. ಸೊ ಎಷ್ಟು ಡೆವಲಪ್ ಮಾಡ್ತಾನೆ ಅಂತ ಕಂಡುಹಿಡಿಬೇಕು ಅಂದ್ರೆ ದಟ್ ಹೌ ಮಚ್ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ವ್ಯಾಲ್ಯೂ, magnitude of that, and how much magnitude of shear stress means I'm going to use this equation. So this is called stress norm transformation equation. Here you can, if you know theta, if you know tau, sigma y, if you know sigma x, everything, if you substitute, you will get what is the principal stress and what is the maximum shear stress going to be developed. So now at particular each angle you can able to calculate what is the stress, what is the shear stress, what is the normal stress. So this is called what we know at particular when you are going to rotate the plane. What is happens now, ಈಗ ಪ್ಲೇನ್ ಹಿಂಗಿದೆ, ನಾನೇನ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಟಿಲ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಈ ತರ ರೊಟೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ, ಹಿಂಗಿದೆ. ಈಗ ಒಂದು ಪ್ಲೇನ್ ತಗೊಳ್ಳಿ, ಈಗ ಇದನ್ನ ನಾನು ಹಿಂಗ್ ಟಿಲ್ಟ್ ರೊಟೇಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ರೊಟೇಟ್ ಮಾಡ್ಬೇಕಾದ್ರೆ ಏನಾಗುತ್ತೆ, ಐ ಆಮ್ ಗೋಯಿಂಗ್ ಟು rotating at particularly one angle, the shear stress becomes zero and only normal stress will be developed, and that stress is called which stress? That stress is called which stress? It is called principal stress. Now that is called principal stress. Now what is that particular angle? Only principal stress will be developed. That is only like in a plane stress sigma and sigma, whereas tau is not with a zero. What particular that angle? ಸೊ ಅದನ್ನ ಮಾಡಬೇಕು ಅಂದ್ರೆ ನಾನು ಏನ್ ಮಾಡಬೇಕು, ಈ ಸ್ಟ್ರೆಸ್ ಟ್ರಾನ್ಸ್ಫಾರ್ಮೇಶನ್ ಈಕ್ವೇಶನ್ ನ ಯೂಸ್ ಮಾಡಿಕೊಂಡು ಥೀಟಾ ವ್ಯಾಲ್ಯೂ 0 ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿದ್ರೆ 0, 1 ಡಿಗ್ರಿ, 2 ಡಿಗ್ರಿ, 3 ಡಿಗ್ರಿ ಅಂತ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡು ಹೋಗ್ಬೇಕು. ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಏನಾಗ್ಬಿಡುತ್ತೆ, ಈ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಎಲ್ಲ 0 ಆಗ್ಬಿಡುತ್ತೆ, ಇದು ಮಾತ್ರ ಮ್ಯಾಕ್ಸ್ ಇರುತ್ತೆ. ಅಂದ್ರೆ ನನಗೆ ಆಗ ಗೊತ್ತಾಗುತ್ತೆ, ಓ ದಟ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ಲೇನ್ the shear stress becomes 0 and only maximum principal stress will be there, and that plane is called principal plane. So what is happens here now, this is become more tedious. Suppose ನಾನು ಪ್ರತಿ ಒಂದು ಆಂಗಲ್ಗೂ ಕಂಡುಹಿಡಿಬೇಕು ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಇದು ಅಂತಂದ್ರೆ ಏನಾಗುತ್ತೆ, ಇಟ್ ಇಸ್ ಬಿಕಮ್ ಮೋರ್ tedious because ಈ ಈಕ್ವೇಶನ್ಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ನಾನು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡ್ತಾ ಹೋಗ್ಬೇಕಾಗುತ್ತೆ. So when I going to substitute and calculate how the variation of shear stress, normal stress take place, you can observe that is in a graph. So x-axis is a theta and y-axis is a stress. There are two types of stress. One is normal stress and one is shear stress. That variation you can observe here. What is that observation you can do is, you can see here, year 1, that is this color, what you can see, green color, it is called normal stress. What is the blue color curve you can see, shear stress. ಈ ಕರ್ವ್ ಯಾವ ತರ ಬರುತ್ತೆ ಅಂದ್ರೆ, ಈ ಈಕ್ವೇಶನ್ಗೆ ನೀವು ಥೀಟಾ ವ್ಯಾಲ್ಯೂ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ 0 ಇಂದ ಸ್ಟಾರ್ಟ್ ಮಾಡಿ ಟು 360 ಡಿಗ್ರಿ ತಗೋತೀನಿ ಅಂದಾಗ ಅವಾಗ ಏನಾಗುತ್ತೆ, ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ವೇರಿಯೇಷನ್ ಈ ತರ ಬರುತ್ತೆ, ಇನ್ನೊಂದು ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ವೇರಿಯೇಷನ್ ಹಿಂಗ್ ಬರುತ್ತೆ. ಥಿಂಗ್ಸ್ ಆರ್ ವೆರಿ ಕ್ಲಿಯರ್ ಇನ್ ದಿಸ್ ಗ್ರಾಫ್. ನೌ ಐ ವಾಂಟೆಡ್ ಟು ಚೆಕ್ your how you are going to analyze this graph. Now by observing the variation of normal stress, that is this one, and shear stress, bottom graph, can you find out what kind of variation of these stresses will be happening now while increasing the angle quickly? ಇದು ನಿಮ್ಮ ಅನಾಲಿಸಿಸ್ ನಾಲೆಡ್ಜ್ ನ ಇಂಡಿಕೇಟ್ ಮಾಡುತ್ತೆ. ಈ ಗ್ರಾಫ್ ನೋಡ್ತಾ ಇದ್ದೀರಲ್ವಾ, ಆಂಗಲ್ ಜಾಸ್ತಿ ಆಗ್ತಾ ಇದೆ, ಎರಡು ಸ್ಟ್ರೆಸ್ ಒಂದ್ ಕಡೆ ಒಂದ್ಸತಿ ಜಾಸ್ತಿ ಆಗ್ತದೆ, ಇನ್ನೊಂದ್ ಕಡೆ ಕಡಿಮೆ ಆಗ್ತದೆ. ಈ ಬಿಹೇವಿಯರ್ ನೀವು ಅಬ್ಸರ್ವ್ ಮಾಡಿ ಏನ್ ನಿಮ್ಗೆ ಗೊತ್ತಾಗುತ್ತೆ ಹೇಳಿ. Am I audible?
Yes, sir.
ಅಟ್ಲೀಸ್ಟ್ ಅದಕ್ಕೆ ಈಗ ಹೇಳಿ, ಈ ಗ್ರಾಫ್ ಇಂದ ಕ್ವಿಕ್ ಆಗಿ ಹೇಳ್ಬೇಕು. ನಿಮ್ಮ ಅನಾಲಿಸಿಸ್ ಇದೆ ಇಂಜಿನಿಯರ್ಸ್ ಅಲ್ಲಿ, ಫಸ್ಟ್ ಥಿಂಗ್ಸ್ ಇಸ್ ಅನಾಲಿಸಿಸ್. ವೈ ಸೀಯಿಂಗ್ ದ ಡ್ರಾಯಿಂಗ್ ಯು ಶುಡ್ ಅನಲೈಸ್. ಈಗ ನನಗೆ ಬೇಕಾಗಿರೋದು ಈ ಗ್ರಾಫ್ ನೋಡಿ, ನಿಮ್ಗೆ ಏನ್ ಅನಾಲಿಸಿಸ್.
ಸೊ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ನೆಗೆಟಿವ್ ತೋರಿಸ್ತಾ ಇದೆ.
Okay, good. That is a good observation. Shear stress will be in negative region. It goes to positive as well as negative, whereas normal stress only positive region. That's good observation. Appreciate. Next, come on. ಇನ್ನು ಇದೆ.
ಸರ್ ಅಟ್ ಸಮ್ ಪಾಯಿಂಟ್ ಅದು ಈಕ್ವಲ್ ಪೀಕ್ಸ್ ಅಲ್ಲಿ ಇದೆ. ಓಕೆ,
ಯಾವ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಈಕ್ವಲ್ ಇದೆ, ಎಷ್ಟು ಡಿಗ್ರಿ ಈಕ್ವಲ್ ಇದೆ? ಅದು ಈಕ್ವಲ್ ಅನ್ನಕ್ಕಿಂತ ನೋಡಿ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ, ಈಕ್ವಲ್ ಇದೆಯಾ? ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಎರಡು ಈಕ್ವಲ್ ಬಂದಿದೆಯಾ ನೋಡಿ, ಅಬ್ಸರ್ವ್ ಮಾಡಿ. ಯು ಆರ್ ನಿಯರ್ ಟು ದಟ್ ಆನ್ಸರ್. ಎನಿ ಅದರ್ಸ್ ಪ್ಲೀಸ್ ಅಬ್ಸರ್ವ್ ದಿಸ್ ಗ್ರಾಫ್. ಎಲ್ಲರಿಗೂ ಗ್ರಾಫ್ ರೀಡ್ ಮಾಡಕ್ ಬರುತ್ತಲ್ವಾ, ಹೇಳಿ. See, the things are very crucial point here you to observe here. We put a narrow mark here. What is the shear stress value at this point? ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಏನಿದೆ? ಈ ಪಾಯಿಂಟ್ ಅಲ್ಲಿ 0 ಇದೆ, because it touches the baseline, whereas the max, what is normal stress here? What is normal stress value? ಏನಾಗಿದೆ? ಒಂದ್ ಕಡೆ
maximum
minimum ಇದೆ, ಇನ್ನೊಂದ್ ಕಡೆ minimum ಇದೆ. What is that angle? You can observe here. Around 30, ಇಲ್ಲಿ ಎಷ್ಟೋ ಇದೆ? That angle can't be. Okay, let it be angle 40 degree. ಇಲ್ಲೊಂದು ಏನು ಇದು, ಇಲ್ಲೊಂದು ಎಷ್ಟೋ ಇದೆ, 100. Okay, angle ಇರಲಿ. So particularly I will tell you, so in between the 90 degree difference of this angle will be between this here is theta will be 90 degree. That is 90 degree difference angle ಅಲ್ಲಿ one, what happened, theta will the shear stress becomes 0, whereas the stress, normal stress go to one is maximum and one side is minimum. Okay, so these are things is going to happens now. ಸೊ ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ನಿಮಗೆ ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಡೆವಲಪ್ ಆಗೋದು ಇವೆರಡು ಕೇಸಲ್ಲಿ ಮೇನ್. ಯಾಕಂದ್ರೆ ಇಲ್ಲಿ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಎರಡು ಕಡೆ 0 ಇದೆಯಲ್ಲ, ನಾ ಹೇಳಿದ್ನಲ್ಲ, ಪ್ರಿನ್ಸಿಪಲ್ ಸ್ಟ್ರೆಸ್ ಯಾವಾಗ ಡೆವಲಪ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಮ್ಯಾಕ್ಸಿಮಮ್ ಯಾವಾಗ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ 0 ಇದ್ದಾಗ. ಸೊ ಇದನ್ನ ಈ ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಅಲ್ಲಿ ಸೊ ಏನಾಗುತ್ತೆ ನಿಮ್ಗೆ ಹಿಂಗೆ ರೊಟೇಟ್ ಮಾಡಿದಾಗ ಯಾವುದೋ ಒಂದು ಪರ್ಟಿಕ್ಯುಲರ್ ಆಂಗಲ್ ಸೇ 40 ಡಿಗ್ರಿ ಮತ್ತೆ ಇನ್ನೊಂದು 120 ಡಿಗ್ರಿ, ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಒಂದ್ ಕಡೆ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಜಾಸ್ತಿ ಆಗುತ್ತೆ, ಒಂದ್ ಕಡೆ ಮಿನಿಮಮ್ ಸ್ಟ್ರೆಸ್ ನಾರ್ಮಲ್ ಸ್ಟ್ರೆಸ್ ಮಿನಿಮಮ್ ಇರುತ್ತೆ, ಬಟ್ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಮಾತ್ರ 0 ಇರುತ್ತೆ. ಆ ಪರ್ಟಿಕ್ಯುಲರ್ ಪ್ಲೇನ್ ಅನ್ನ ಏನ್ ಪ್ಲೇನ್ ಅಂತ ಕರಿತೀವಿ? ವಾಟ್ ಇಸ್ ದಟ್ ಪ್ಲೇನ್ ಕಾಲ್ಡ್ ಆಸ್? ವಾಟ್ ಇಸ್ ದಟ್ ಪ್ಲೇನ್ ಕಾಲ್ಡ್ ಆಸ್? Principal plane. So things are, what is happening here, in order to find out this, it's very difficult. ಯಾಕಂದ್ರೆ ನಾನು ಪ್ರತಿ ಒಂದಕ್ಕೂ ನನ್ನ ಆಂಗಲ್ ನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ I need to check this. In order to overcome this problem, the person work on this to find out this in a graphical way, easiest to find out the any principal stresses at any particular angle. That is known as Mohr's circle. That is what we are going to take up now, the last concept. So Mohr's is the name of a scientist. He worked on this, developed this concept. We can able to calculate the principal stresses as well as the shear normal stress as well as the shear stresses at any particular angle. By using this in a graphical method, we can able to calculate the principal stresses like sigma 1, sigma 2, sigma 3, even for the 2D case, even for the 3D case, it is become very easy way. So that diagram is called as Mohr's circle. Mohr's circle is a graphical method for easily determining the normal and shear stresses without using any stress transformation equation. Which is the stress transformation equation? This is the stress transformation equation. Is it clear?
Yes sir.
Okay, so let me see then how these things are work in the graphical way. So basically graphs means we are going to represent in a 2D form. Therefore there are two reference axis should be there. Same thing here also in the Mohr circle also. One horizontal axis represent the normal stress, one vertical axis represent the shear stress. So above this horizontal, this is represent the negative shear stress. Here the value will be in the downward is called, all the represent in a positive shear stress. Topward is negative shear stress, bottom is positive shear stress will be there. So now take now how to get these values through this graphical method. So now what you have to do, so we have to draw, first take up the reference of these two lines, divide into the like values with the help of scale. So now this is the problem. Now I have the sigma x, I have the sigma y, and also I have the tau xy value. So here we are going to take up the sign convention like this. If these two pair of two shear stresses, if rotate in a clockwise direction, then we consider the things are shear stress in a positive, which the shear stress will rotate in a clockwise means it is considered as negative. So adar prakara ee shear stress rotate ಆಗ್ತಾ ಇರೋದು clockwise anti clockwise? Anti clockwise. ಇದು clockwise. Then we consider for this two case, idu positive shear, idu negative shear. So ivaga sigma x sigma y nimge tau x by value godutte, adar prakara ಏನು ಮಾಡಬೇಕು, you have to mark the points. ನನಗೆ ಈಗ sigma x ಎಷ್ಟು ಗೊತ್ತಿದೆ, ಸೊ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಗೊತ್ತಿದೆ, ಲೆಟಸ್ ಸೇ 100 ಮೆಗಾ ಪ್ಯಾಸ್ಕಲ್ ಅನ್ಕೋಣ. ಸಿಗ್ಮಾ ವೈ ಗೊತ್ತಿದೆ, ಲೆಟಸ್ ಸೇ 200 ಮೆಗಾ ಪ್ಯಾಸ್ಕಲ್. ಅದೇ ತರ ಟೌ ಎಕ್ಸ್ ವೈ ಅರೌಂಡ್ 50 ಮೆಗಾ ಪ್ಯಾಸ್ಕಲ್ ಅಂತ ತಿಳ್ಕೊಳ್ಳೋಣ. ಸೊ ಈಗ ಪಾಸಿಟಿವ್ ಶಿಯರ್ ಎರಡು ವ್ಯಾಲ್ಯೂ ಸೇಮು, ಪಾಸಿಟಿವ್ ಶಿಯರ್ ಬಟ್ ನೆಗೆಟಿವ್ ಶಿಯರ್ ಡಿಪೆಂಡ್ ಅಪಾನ್ ದ ಡೈರೆಕ್ಷನ್ ಆಫ್ ರೊಟೇಷನ್, ಅದಷ್ಟೇ ಚೇಂಜಸ್ ಇರುತ್ತೆ. ಈಗ -50 ಅಂದಾಗ ನಾನು ಇಲ್ಲಿ ಮೇಲ್ಗಡೆ ಬರ್ತೀನಿ, -50. ಸಿಗ್ಮಾ ವೈ ಸಮ್ ವ್ಯಾಲ್ಯೂ ಇರುತ್ತೆ, ಸೇ ಇವಾಗ ಹೇಳಿದೆ ನಮ್ಮ ಪ್ರಕಾರ ಸಿಗ್ಮಾ ವೈ ಎಷ್ಟು ಹೇಳಿದೆ ನಾನು ಇಲ್ಲಿ ಜಾಸ್ತಿ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸಿಗ್ಮಾ ಎಕ್ಸ್ ನ ಎಕ್ಸಾಂಪಲ್ ಪ್ರಕಾರ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ನ 300 ತಗೋಣ, ಸಿಗ್ಮಾ ವೈ ನ 100 ತಗೋಣ. ಯಾಕಂದ್ರೆ ನಾನು ಇಲ್ಲಿ ಮಾರ್ಕ್ ಮಾಡ್ತೀನಿ 100, 200. ಓಕೆ, ಲೆಟ್ ಮಿ ಅರೇಸ್, ಸ್ವಲ್ಪ ಕನ್ಫ್ಯೂಸ್ ಆಗ್ತದೆ ಅನ್ಸುತ್ತೆ. ಲೆಟ್ ಮಿ ಅರೇಸ್. ಓಕೆ, ಐ ವಿಲ್ ಮಾರ್ಕ್ ಇನ್ ಎಲ್ಲೋ, ದಟ್ ಇಸ್ ಬೆಟರ್. ಓಕೆ, ದಿಸ್ ಒನ್ ಇಲ್ಲಿ ಫಸ್ಟ್ ಮಾರ್ಕ್ ಮಾಡ್ತೀನಿ, ಅಲ್ಲಿ 100, 200 ಮೆಗಾ ಪ್ಯಾಸ್ಕಲ್, 300 ಮೆಗಾ ಪ್ಯಾಸ್ಕಲ್. ಅದೇ ತರ ನಾನು ವಿಲ್ ಮಾರ್ಕ್ ದ ಶಿಯರ್ ಸ್ಟ್ರೆಸ್ ಇನ್ ಬೋತ್ ಡೈರೆಕ್ಷನ್. That is called as 10. Okay, let me call it as here 20, 40. Okay, ಅದೇ ತರ ಇಲ್ಲಿ 60 ತಗೋಣ, ಒಂದು ಯೂನಿಟ್ ನ 20 ತಗೋತೀನಿ. ಅದೇ ತರ ಇಲ್ಲಿ -20, -40, -60. ಈಗ ನಾನು ಎಕ್ಸಾಂಪಲ್ ಹೇಳಿದೆ, ನಾನು ಎಕ್ಸಾಂಪಲ್ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಎಷ್ಟು ತಗೋತೀನಿ ಅಂದ್ರೆ 300 ಇದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಸಿಗ್ಮಾ ವೈ ಒಂದು 100 ಇದೆ ಅನ್ಕೊಳ್ಳಿ. ಅದೇ ತರ ಟೌ ಎಕ್ಸ್ ವೈ ಒಂದು 50 ಇದೆ ಅನ್ಕೊಳ್ಳಿ. ಸೊ ಅವಾಗ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಇದ್ರ ಗ್ರಾಫ್ ಪ್ರಕಾರ 200 ತಗೋಣ. ಸಿಗ್ಮಾ ಎಕ್ಸ್ ನಾಟ್ 300, 200 ಅಂದ್ರೆ ಎಲ್ಲಿ ಬರುತ್ತೆ, ಇಲ್ಲಿ ಬರುತ್ತೆ. 50 -50 ಅಂದ್ರೆ ಎಲ್ಲಿ ಬರುತ್ತೆ, ಈಗ -50 ಎಲ್ಲಿ ಬರುತ್ತೆ, ಬಾಟಮ್ ಅಲ್ಲಿ, ಕರೆಕ್ಟಾ? ಎಸ್, ಇಲ್ಲಿ ಬರುತ್ತಾ? ಮಾರ್ಕ್ ಮಾಡ್ತೀನಿ. ಅದೇ ತರ ಸಿಗ್ಮಾ ವೈ 100 ಅಂತಿದೆ, 100 ಅಂದ್ರೆ ಇಲ್ಲಿ. ಅದೇ ತರ ಮೈನಸ್ ಟೌ ಎಕ್ಸ್ ವೈ ಬಂದು +50, ಟೌ ಎಕ್ಸ್ ವೈ ಬಂದು +50. ಐ ವಿಲ್ ಮಾರ್ಕ್ ದಿಸ್ ಹಿಯರ್. So now I got 2 points, isn't it? I got 2 points, right? Yes or no?
Yes, sir. Yes, sir.
So now what I'm going to do, I'll join the line through this. So now where the line will be cut, this horizontal axis of sigma, this here how much will be there? How much will be there here?
0.
What is the value of sigma? What is the value of tau become here? Tau ಏನಿರುತ್ತೆ ಇಲ್ಲಿ tau ಏನಿರುತ್ತೆ ಇಲ್ಲಲ್ಲ, ಇಲ್ಲಿ ಎಲ್ಲೇ ತಗೊಂಡು tau ವ್ಯಾಲ್ಯೂ ಏನಾಗುತ್ತಪ್ಪ?
0.
0. But what about the sigma x and sigma y? It is divided by 2, right? Radius ತಾನೆ, ಇಲ್ಲಿಂದ ಇಲ್ಲಿಗೆ ಏನಿರುತ್ತೆ, ಅದು ಅರ್ಧ ಇರುತ್ತೆ. Yes or no?
Yes,
okay,
sir.
this is at the center, sigma x plus sigma y by 2. So now what I'll I'll take a compass and with respect to radius of this much, and I'll draw one circle. So this circle is called which circle? This circle is called which circle? Mohr circle. So even you can able to calculate the radius of the Mohr circle using this equation. Okay. So now where this circle at the extreme end of this, where it will touch here, that is here and here on the sigma x axis. So this is called a sigma 1 and this is called a sigma 2 will be there. So now you can just take a scale and measure this, you'll get the values of sigma and sigma 2 very easily. So this is equal to this equation. How? We can see here. So ಇಲ್ಲಿಂದ ಸಿಗ್ಮಾ 2ಗೆ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಇರುತ್ತೆ ಅಂದ್ರೆ, ಇಟ್ ಈಸ್ ನಥಿಂಗ್ ಬಟ್ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಪ್ಲಸ್ ಸಿಗ್ಮಾ ವೈ ಹೋಲ್ ಡಿವೈಡ್ ಬೈ 2. ಅದೇ ತರ ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಸಿಗ್ಮಾ 1ಗೆ ಎಷ್ಟು ಸೆಂಟರ್ ಇಂದ ಎಷ್ಟು ಡಿಸ್ಟೆನ್ಸ್ ಇರುತ್ತೆ ಅಂದ್ರೆ, ದಿಸ್ ಮಚ್ ರೂಟ್ ಆಫ್ ಸಿಗ್ಮಾ ಎಕ್ಸ್ ಬೈ 2 ಹೋಲ್ ಸ್ಕ್ವೇರ್ ಪ್ಲಸ್ ಟೌ ಎಕ್ಸ್ ವೈ. ಇವೆರಡನ್ನು ಆಡ್ ಮಾಡಿದ್ರೆ ನಿಮ್ಗೆ ಏನ್ ಸಿಗುತ್ತೆ, ಸಿಗ್ಮಾ 1 ಸಿಗ್ಮಾ 2. ದಟ್ ಈಸ್ ವಾಟ್ ಯು ಆರ್ ಯೂಸಿಂಗ್ ಅನಾಲಿಟಿಕಲಿ ದಿಸ್ ಈಕ್ವೇಶನ್. ಅಂದ್ರೆ ಇನ್ಸ್ಟೆಡ್ ಆಫ್ ಇಲ್ಲಿ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡೋ ಬದಲು ಸಿಗ್ಮಾ 1 ಸಿಗ್ಮಾ 2, very easiest way we can able to get the sigma 1 sigma 2. That is the beauty of this Mohr circle. Clear? This is for 2D case, and similarly for 3D case there will be another principal stress will come, that is called sigma 3. Then we are going to draw the 3 circle. One big circle will represent the outside extreme point is called sigma 1 and sigma 2. And in between that there are going to draw the 2 more circle where these 2 circle will be intersect, and that is called a sigma 2. So that is, we will get sigma 1 sigma 2 sigma 3. This is in case of 3D case. Very easily we will get it. Instead of substituting and computation method it will be ready, take up much time, but here we'll get it very less time. For any kind of values, we'll get it easily to find the all the principal stresses in a 3D forum as well as 2D forum using a graphical method. That is known as Mohr circle. Is it clear?
Yes, sir.
So by this, I think hope all the concept of the strength of material, most of things, which is a basic part, which is you want to learn, that I taught in all the 4 videos. Hope you learned something about our mom. You got to know the knowledge. Yes or no?
Yes, sir.
Everyone, please go one time. I told you one time itself will not get into that. Please, you have to go through many a times.